Have you ever wondered how your eyes can turn light into the vibrant, colorful world you see? Imagine a world where everything you see is nothing but a blur. What if the vibrant colors, the intricate details, and the magic of sight suddenly vanished? Your eyes, those incredible windows to your soul, hold secrets so fascinating they'll leave you in awe. Want to know how they work and why they're the ultimate masterpiece of evolution? Stay tuned, because you're about to see your eyes in a whole new light. The eye is a sensory organ responsible for vision. It works by capturing light and converting it into electrical signals that your brain interprets as images. The eyeball consists of 3 layers: the outer fibrous layer, the middle vascular layer or uvea, and the inner nervous layer or retina. The outer fibrous layer includes the cornea and sclera. The cornea forms the anterior 1/6 of this layer and is a clear transparent structure responsible for allowing light to enter the eye. It acts as the principal refractive surface and a protective barrier. Think of the cornea as your eye's built-in camera lens. Just like a photographer adjusts focus, your cornea bends light to give you that sharp, crisp vision. Did you know the cornea doesn't have a single blood vessel? How does it survive? It gets oxygen straight from the air you breathe. The sclera forms the posterior 5/6 of the outer layer. It is a dense, opaque, connective tissue layer, giving the eye its white appearance. It has 3 layers: episcleral tissue, sclera proper, and lamina fusca. The sclera is thinnest and weakest posterior to the recti muscle insertions. The limbus is the transitional zone between the cornea and sclera. It houses corneal stem cells, which regenerate the corneal epithelium. Limbal injuries can lead to the invasion of conjunctival epithelium into the cornea, causing loss of transparency, often managed with limbal cell transplantation. The middle vascular layer or uvea includes the iris, ciliary body, and choroid. The iris, the anterior-most part, is a circular colored structure with a central aperture called the pupil. Your iris is like the aperture of a camera, controlling how much light enters. The pattern of your iris is so unique that no two are alike. Even twins have different ones. Could your eyes be the ultimate personal ID? The iris contains 2 muscles: the sphincter pupillae, responsible for constricting the pupil, and the dilator pupillae, which dilates the pupil. Blood supply to the iris is through the major and minor arterial circles formed by the anterior and posterior ciliary arteries. The ciliary body, located between the choroid and iris, has 2 parts: the anterior pars plicata with ciliary processes and the posterior pars plana. The ciliary muscle, innervated by parasympathetic fibers, adjusts lens shape for accommodation. Zonular fibers extending from the ciliary processes suspend the lens and help in its positioning. The ciliary processes also secrete aqueous humor, which nourishes the avascular structures of the eye. The choroid is the posterior part of the uvea, extending from the optic disc to the ora serrata. It is highly vascular, providing 85% of the blood supply to the eye. It is firmly attached to the retina and loosely to the sclera. The lens is a transparent, biconvex and elastic structure located between the iris and vitreous in the patellar fossa. Surrounded by a hyaline capsule, it is avascular and suspended by zonular fibers from the ciliary body. Its cortex contains younger fibers, while the nucleus consists of older fibers, further divided into embryonic, fetal, infantile, and adult zones. The lens has a refractive power of 18D, a refractive index of 1.39, and relies on anaerobic glycolysis for metabolism. Picture the lens as an acrobat, constantly flexing to focus on far and near objects. Ever struggled with blurry close-up text as you age? That's because the lens loses flexibility over time, a natural condition called presbyopia. The iris lens diaphragm divides the eye into anterior and posterior segments. The anterior chamber lies between the cornea and iris, containing 0.25 milliliters of aqueous humor, while the posterior chamber between the iris and lens holds 0.06 milliliters. Aqueous humor, produced by the ciliary processes, supports the cornea and lens. It drains through trabecular and uveoscleral outflows, maintaining intraocular pressure. Imagine a jelly-filled balloon inside your eye. That's the vitreous humor, maintaining the eye's shape and allowing light to travel unobstructed. The vitreous cavity behind the lens contains 4 milliliters of jelly-like vitreous humor formed only at birth, composed of water, collagen, and hyaluronic acid. It stabilizes the eye and nourishes the retina. Both aqueous and vitreous humors play essential roles in ocular health and vision, with the former supplying nutrients and the latter providing structural support. Ever notice tiny floating specks in your vision? They're shadows cast by debris in the vitreous humor. The inner nervous layer or retina is a thin transparent membrane extending from the optic disc to the ora serrata. The retina is like a high-definition movie screen, packed with millions of rods and cones. The central retina or posterolateral optic part is light-sensitive, with specialized areas like the macula lutea and fovea centralis. The macula is a small central area in the retina responsible for detailed vision. Think of the macula as your personal spotlight, helping you read, recognize faces, and see fine details. The fovea, located within the macula, is the most sensitive structure for light due to its abundance of cones and absence of rods. It is responsible for high visual acuity. The optic disc, also called the blind spot, is where the optic nerve begins, and no photoreceptors are present. Imagine your optic nerve as a lightning-fast courier, delivering visual messages to the brain at the speed of thought. But here's the twist. Did you know your optic nerve creates a blind spot? Why don't you notice it? The brain is a master illusionist, filling in the gaps seamlessly. The optic nerve creates a natural blind spot in your vision, but your brain fills it in seamlessly. The retina contains two types of photoreceptors: rods, which are responsible for night and peripheral vision, and cones, which enable color vision and function in bright light. Rods act like night vision goggles, while cones are the artists painting your world in vibrant colors. The human retina contains about 120 million rods and 6 million cones. What if I told you the retina is capable of detecting a single photon of light? How incredible is that? Blood supply to the retina is dual. The inner two-thirds are supplied by the central retinal artery, while the outer one-third receives blood from the choroidal circulation. The retinal pigment epithelium, RPE, the outermost layer of the retina, provides metabolic support and maintains retinal adhesion. How vision works. Light enters the eye through the cornea and passes through the pupil, where its intensity is regulated by the iris. It's like opening a door to let just the right amount of sunlight into a room. The lens then bends or refracts the light to focus it onto the retina. Imagine adjusting a telescope to get a clear view of distant stars. The cornea provides most of the refraction, while the lens fine-tunes it. The retina converts light into electrical signals through photoreceptor cells, namely rods and cones. Rods help you see in dim light but don't detect color. Cones, concentrated in the fovea, are responsible for color vision. How does your brain turn these signals into the vivid images you see? That's the magic of the visual cortex. The optic nerve sends these electrical signals to the visual cortex in the brain, which processes and interprets them as images. It's like a high-speed internet connection, ensuring zero lag in your vision. Humans can distinguish around 10 million colors thanks to 3 types of cones sensitive to red, green, and blue wavelengths. People with color blindness experience the world differently, like seeing a rainbow in grayscale. Color blindness occurs when one or more cone types are defective or absent. Now let us discuss the common eye conditions and the hidden dangers associated with them. Refractive errors include myopia or nearsightedness, which is difficulty seeing distant objects due to the eye being too long or the cornea too curved. Hyperopia or farsightedness is difficulty seeing close objects due to the eye being too short. Astigmatism causes blurred vision and is due to an irregularly shaped cornea. Cataracts are the clouding of the lens, leading to blurry or dim vision, and are common with aging. Imagine looking through a foggy window. Cataracts cloud your lens, making vision dim and blurry. Glaucoma involves damage to the optic nerve due to increased pressure in the eye, which can lead to blindness. Macular degeneration is the deterioration of the macula, resulting in loss of central vision. It's like losing the central part of a puzzle. Your vision loses sharpness right where it matters most. Dry eye syndrome happens when insufficient tear production leads to discomfort and blurry vision. Let us know some interesting facts about eyes. Did you know humans can distinguish up to 10 million colors but can only see about 1% of the electromagnetic spectrum? What colors are we missing out on? Your eye muscles are the fastest in your body, allowing you to blink in just 0.1 seconds. Newborns only see in shades of gray and start perceiving color after a few weeks. The eyes are so powerful that they can process 36,000 pieces of information per hour. On average, you blink 15 to 20 times per minute, or around 28,000 times per day. How to take care of your eyes. Let's learn 4 proven tips. First up, nutrition. Eat foods rich in vitamin A, omega-3s, and antioxidants to keep your eyes healthy. Vitamin A supports the retina and is found in carrots and sweet potatoes. Omega-3 fatty acids promote retinal health and can be found in fish like salmon. Antioxidants protect against damage and are present in leafy greens and berries. Second, protection. Wear sunglasses to block harmful UV rays. Use safety goggles during activities that could injure your eyes. Third, reduce screen strain. Follow the 20-20-20 rule. Every 20 minutes, look at something 20 feet away for 20 seconds. Fourth, regular eye checkups. Visit an eye doctor regularly to detect issues early. Early detection of conditions like glaucoma can save your vision. Lastly, where is the future of ophthalmology? Let's take a glimpse into the future. First up, bionic eyes. Prosthetic devices are being developed to restore vision in people with severe eye damage or blindness. Next, gene therapy. Promising advancements aim to treat genetic causes of blindness, such as retinitis pigmentosa. Next, stem cell therapy. It could potentially regenerate damaged retinal cells in conditions like macular degeneration. Lastly, artificial intelligence. AI-powered tools are revolutionizing early detection of eye diseases like diabetic retinopathy. In essence, your eyes are a marvel of biological engineering, working tirelessly to connect you to the world around you. From the intricate anatomy to the complex processes that allow you to see, the science of eyes is nothing short of extraordinary. Your eyes are more than just a tool for sight. They're storytellers, navigators, and a gateway to the beauty of life. So take a moment to appreciate the wonders they bring. By taking good care of your eyes today, you can ensure they continue to dazzle you with the beauty of the world for years to come. See you next time. Keep watching MedGroww and take care of yourself.